Hey ninth graders, welcome to Chapter 3, Lesson 3. In this video, we're going to be talking about rate of change and slope. Hopefully those words look familiar to you. This is kind of like a quick review lesson. So our objective is to use rate of change to solve problems, as well as to find the slope of a line. So we have two things we're doing today. We're finding slope, and we're finding rate of change. Now, our standards are functions, interpreting function standard number 6, functions, linear expressions, standard 1 alpha. So these are what we're going to be doing today. Let's go ahead and start looking at some kind of notes to help us out with what we're going to be doing today. Alright, for our first example, what we're going to do is we're going to find the rate of change between this table here. So I'm going to teach you how to find rate of change in the table. Now I wrote three kind of things of what we're going to be doing. The first thing is we're going to find the change in y and we're going to find the change in x, because that's the definition of rate of change. Rate of change is the change in y divided by change in x. It's how something changes over time. Now, anytime that you deal with time, that's always going to be an x value, 90% of the time. So, first thing we're going to do is we're going to find the change in y, change in x. When given a table, you actually want to label your x and y first. So, since this deals with time, I'm going to put that this is the x, and this deals with something other than time, I'm going to put that this is the y. So we have our x values and our y values. Well, again, it says find the change in y. So I'm going to look at the y side first, and I'm going to say, how do I go from 76 to 152? Well, to go from 76 to 152, I'm going to add 76. To go from 152 to 228, I'm going to add 76 again. So right now, my change in y is 76, and it's 76 both times. Well, if we look here, it says if we have the same number, it's going to make a straight line. That's what linear means. And if we can call it linear, we're going to say it has a constant rate of change. If it's not the same, it's going to be nonlinear, which means it doesn't have a constant rate of change. So we have to determine not only what this rate of change is, but if it's linear or nonlinear. So is it going to make a straight line, or is it not? So we need to tell if it is, and if it is, why or why not. It's the same or it's not the same. That's what we're going to explain. So we found the change in y. Now we have to find the change in x. To go from 2 to 4, we're going to add 2. To go from 4 to 6, we're going to add 2. So right now, I can see that my rate of change is 76 on the y and 2 on the x. And it's always the same number. It's always 76. It's always 2. In this case, I have a constant rate of change because it's always the same number. So my rate of change, in this case, is going to be the change in y over change in x. So my rate of change in this case is 76 miles, because that's what the y is labeled, over 2 hours. So that means that this person is going 76 miles in 2 hours. And if I simplify that, I'm going to get 38 miles in 1 hour. So my rate of change in this problem is 38 miles to 1 hour. Alright, so we learned how to find rate of change in a table. All we do is find the change in y, change in x, and then we make it change in y over change in x, and then we label, and that's our answer. So in this problem, we're going to be finding the rate of change between passports in millions and the year. So how many passports were given out in the United States in a particular year. So the first thing we're going to do is we're going to find rate of change from 2013 to 2014. We're going to find rate of change from 2014 to 2015. So we're going to find rate of change from this point to this point. And then we're going to find rate of change from this point to that point. Now, looking at this graph, hopefully you can tell which one is probably going to have a bigger rate of change. A bigger rate of change means that the graph is going to be a little bit steeper. It's going to go up at a faster rate. If you have a big rate of change, you're going to go up fast. If you have a small rate of change, like right here, you're going to go up slow. So we're going to have to find these two rates of change. Well, rate of change is the change in y over the change in x. And so whenever looking at a graph, you always want to label what's your y, and you always want to label what's your x. Now, all we got to do is say, what does the y change by? So that's really saying, as long as you have 2 points on a graph, if you don't have 2 points on the graph, put 2 points on the graph. All you gotta do is say, how much do I go up, then how much do I go over? Because the y is the line that goes up and down. The x is the line that goes left and right. So from this point to this point, I go from 13.1 to 14.1. So I really go up by 1 unit. So my change in y over my change in x, in this case, is 1 over, well, I go from 2013 to 2014. So I'm going 1 year. So my rate of change in this one is 1 over 1, and 1 divided by 1 equals 1. So what that means is I grew by 1 million passports in 1 year. 1 million passports, 1 year. Now, we're going to do 2014, 2015. This time, we're going from 14.1 all the way to 18.7. So, we're going to find the change in y first. How much do I go up or down? And then we're going to find the change in x. So looking at this, I go from 14.1 to 18.7. So our change in y is 4.6. So we grew 4.6 million passports over 2014, 2015, 1 year. And then this one, we grew 1 million. So looking at this, we can see a difference. We had 1 million passports given out from 2013 to 2014. Not too many. But from 2014 to 2015, 4.6 million passports were given out. That's 3.6 million more. So of course this has a higher rate of change. So whenever given a graph, you plot 2 points, you find the change in y, how much do you go up or down, then find the change in x, how much do you go right or left. And that's all we got to do for rate of change. We're going to go ahead and start looking at slope now. Alright, so we got a lot going on this slide. So in this slide, it has all the notes that you should know about slope. The first thing you should know is the definition of kind of what slope is. Slope is the steepness of a line. So slope is how steep some line is. If you have a big slope, it's really steep. If you have a small slope, it goes up slow. We have 4 different types of slopes. We have a positive slope, and a positive slope goes up from left to right. We have a negative slope, and a negative slope goes down from left to right. We even have a slope that doesn't go up or down. That's called no slope or zero slope. And the last one here is an undefined slope. An undefined slope is a slope that you can't tell whether or not it's going up or down. Now, to tell the difference between these, a zero slope is whenever you have 0 on the top. So 0 divided by some number is a zero slope. You're not going up any, you just go across. An undefined slope is where you have a number on top of your slope, but you have 0 on the bottom. So anytime you have 0 on the bottom, that means you're not going to go right or left, but you are going to go up or down. And this will make sense once we actually start graphing by using slope. So, we have 4 different types of slope: positive, negative, no slope, and undefined. And if it's no slope, that means 0's on the top. And if it's an undefined slope, that means 0's on the bottom. That's one thing to remember. Now, slope is exactly the same thing as rate of change. It's the change in y divided by the change in x. Some people know slope as the words rise over run. That's because slope kind of tells you directions. The rise tells you to either move up or down, and the run tells you to move right or left. And so I'm telling you that this is telling you to move the graph. So it's how you plot additional points. We can use slope to plot additional points. Now, the equation for slope is equal to the letter m in mathematics. And m is equal to our y2 coordinate minus our y1 coordinate divided by our x2 coordinate minus our x1 coordinate. Whenever you're told to find slope between 2 points, what you want to do is you want to label x1, y1, x2, y2. Take your y2 minus y1, x2 minus x1. And whatever answer you get is going to tell you if you have a positive slope, that means you have a positive answer. Negative slope, you have a negative answer. No slope, which means you'll have a 0 on the top and some other number on the bottom. Or an undefined slope, which is going to tell you if you have a number on top and 0 on the bottom. Let's go ahead and find the slope between two coordinate pairs. In our third example, because we've done graphs and we've done tables, so in our third example where we're finding the slope, we're given 2 points. Our job is to figure out how steep this line is and figure out if it's positive, negative, no slope, or undefined. So it says find the slope of the line that passes through negative 3, 4, that's 1 point, and 4, 4. So that would be like if these 2 points were plotted, we have to find out what our rise is and what our run is. So we need to know the equation of slope. And so we always want to write that m, which represents slope, is equal to y2 minus y1 over x2 minus x1. It's very, very important that in 9th grade that you remember this formula. So that's why I put stars around it in the previous slide. So when given 2 pairs of points, what we need to do is we need to label x1, y1, x2, y2. So for me, if I see the coordinate pair first, I usually call that my x1, y1. And if I see the coordinate second, I call that my x2, y2. And if I want to find the slope between these 2 points, what I need to do is I need to take my y2 number, this is the y2 number, I'm going to take 4 minus, because it's y2 minus y1, well y1's 4. So I have 4 minus 4 divided by x2 is 4, so I'm going to write 4. I'm going to put a minus sign, negative 3. So right now, I could tell you what my slope is. It's going to be 4 minus 4, that equals 0, over 4 minus negative 3. Well, I see 2 minuses side by side. And again, I got minus negative 3 because I'm subtracting negative 3. 2 minus signs mean we add. 4 plus 3 is 7. So this slope is 0 over 7. And we know that if there's 0 on top, that this slope would be a graph that looks like this. Which means it's going to have no slope. 0 is my slope on this one. And that's my answer. So if we had to find the slope, this is a 0 slope. We took our y2 minus our y1. That's right here. We took our x2 minus our x1. And that's right there. 0 divided by 7, 0, so our slope is 0. That's the answer to this problem. The graph would look like that. For our next example, we're going to find the slope between 4, 5, and 7, 6. So, first thing we're going to do, we need to have our equation. Slope is equal to y2 minus y1 over x2 minus x1. We label our x1, y1, x2, y2, and again, that's because x always comes before y. And now we just follow that equation over there. We take the y2 value, which is 6, minus the y1 value, 5, over 7, which is the x2, minus x1, 4. So this graph is going to have a slope of 6 minus 5, which is 1, 7 minus 4, that's 3. So what this slope tells me is that I would actually rise 1, and I would run 3. So I would go up 1 and over 3. And since this is a positive slope, that means my graph would look something like this when I'm done. Just knowing that is very important. You should know which way your graph should be pointing. So knowing if your graph is positive is very important. We go up 1, so we go up 1 spot, we go over 3, we put a dot. We go up 1, over 3, put a dot, and you'll see that you form a line. Just know that your graph is going to be positive, so your graph should show it going up. And that's how we find slope. Let's go ahead and do one more, and then we're going to find a missing piece of slope. Alright, for example 4 or 5, example 5, what we're going to be doing is we're going to find the slope from negative 3, negative 5, to negative 2, negative 7. So we're saying that these would connect and they make a line. We have to figure out what type of slope that we have. So we're going to go ahead and call this x1, y1, x2, y2. Now we have to make sure we follow that. y2 first, so negative 7, minus y1, that's a negative 5. over, or divided by, x2, negative 2, minus x1, negative 3. And here I see that I have a minus minus on top. That's going to go ahead and change to positive. And I have a minus minus on bottom. That's going to go ahead and change to positive. So my answer is going to be negative 7 plus 5. That's a negative 2. Negative 2 plus 3. That's a positive 1. So this one is a negative 2 over 1 slope. And since it's a negative slope, my graph should be going down. Now, to show how it goes down, remember that the top number tells me my rise. So I would go down 2. So I'm going to put a dot. I would act like I go down 2, 1, 2. Then I go over 1, put another dot, connect those, and my graph would have a slope that looks something like this. I went down 2 spaces, right 1, and connected the dots. It has a rise of negative 2. Negative means go down. Positive means go right. So my graph would look something like that. And I know that it's negative because it's a negative fraction. So the slope is negative 2 over 1. That's how it looks. We're going to go ahead and switch gears and do the last part of today's lesson. The last part is when given 2 pairs of points and the slope, but there's one piece of the point missing, we can find the missing piece. So that's the algebra part. That's what we're going to be solving today. Alright, for the very final piece of today's lesson, we're going to probably do 1, maybe 2 examples of this. We're going to find the value of r so that the line through 6, 3 and r2 has a slope of 1/2. So we're actually going to be given the slope. It says the slope is 1/2. Now remind yourself that slope is the letter m. So we're given m. m, which is right here, we're given that. The slope is 1/2. So what I would do is I'd rewrite this equation. We're going to go ahead and rewrite m equals y2 minus y1 over x2 minus x1. But we're going to replace the pieces they give us. This is our x1, this is our y1. This is our x2, this is our y2. So we're still given 2 points. We're also given the m. So we're given every piece of this. So that's what we're going to do. Instead of writing m, I'm going to write 1 over 2 equals, so that's my m. So this is m equals y2, that's 2, minus y1, 3, so 2 minus 3, over x2, that's r, minus 6. So what I did was I did m equals y2 minus y1 over x2 minus x1. Reminder, m is 1/2. Slope is 1/2. Now, since we have a fraction equals a fraction, we could cross multiply and divide, but before we do that, we're going to actually solve the piece that we can solve, combine like terms. So we're going to solve what we can. So we're going to rewrite it. 1/2 equals 2 minus 3, that's a negative 1, over r minus 6. So now that we have a fraction times a fraction, we're going to go ahead and cross multiply. 1 times r minus 6, that's 1, and then in parentheses, r minus 6, equals 2 times negative 1, that's negative 2. So we just cross multiplied. Now that we have a number next to parentheses, we can distribute if we want to, or we can actually divide by that number. I'm going to go ahead and distribute. 1 times r, that's 1r. 1 times negative 6, that's negative 6, equals negative 2. So our job is to get r by itself. Hopefully you see that this is a 2-step equation. So if we want to get r by itself, we're going to get rid of minus 6. And to get rid of a minus 6, we're going to add 6. If we add 6 to one side of the equal sign, we have to add 6 to the other side of the equal sign. The 6's are going to cancel out because a negative 6 plus 6 is 0. We have 1r equals negative 2 plus 6. That's a positive 4. If I want to get rid of the r, or the 1 next to the r, I could by dividing. But I know 1 times anything is the same number. So 1 times r is just r equals 4. So in this problem, if I were to put 4 right here, I'd have the correct answer. 2 minus 3 that's negative 1. 4 minus 6, that's negative 2. And a negative divided by a negative is a positive. And I get the same answer that I started with. And that's what we're supposed to get. We're supposed to make our slope 1/2. Our slope is 1/2. We got the right answer.